Good morning students. Today in our video we are discussing a very easiest chapter from the second year topic, so that is dual nature of matter. So here this chapter is very important and a very easiest chapter. A small effort will give you big achievement. So students, ఈ చాప్టర్ని బేసిక్స్ నుంచి తరోగా నేర్చుకుంటూ న్యూమరికల్స్ వరకు వెళ్దాం. సో ఆ తర్వాత మీరు ప్రాక్టీస్ చేసినట్లయితే ఖచ్చితంగా మీరు జేఈ నీట్లో 4 నుంచి 8 మార్క్స్ వరకు గెయిన్ చేయగలరు. సో దిస్ ఈజ్ అవర్ చాప్టర్. ముందుగా మనం లెసన్లోకి వెళ్ళే ముందు ఈ వీడియోని ఎవరైతే మొట్టమొదటిసారిగా చూస్తున్నారో ఈ ఛానల్ని సబ్స్క్రైబ్ చేసుకోండి. ఈ వీడియో నచ్చితే లైక్ చేయండి, షేర్ చేయండి, కామెంట్ చేయండి. మీ విలువైన సందేహాలను డిస్క్రిప్షన్లో రాయండి. సో మీకు వీలైతే నోట్బుక్ తీసుకొని పాయింట్స్ నోట్ చేసుకోండి. సో ఫస్ట్ ఇంపార్టెంట్ పాయింట్ వచ్చేసి రేడియేషన్ ఆఫ్ లైట్. ఇట్ హ్యాస్ two properties, that is wave nature and particle nature. Due to the particle nature, photoelectric effect was established. And so coming to the matter, so matter has also two properties, that is particle nature and wave nature. Due to the wave nature, Davison and Germer experiment was established. So now the third point, that is nothing but Einstein's photoelectric effect. So due to the Einstein's photoelectric effect, so at first coming to the statement, so what is the photoelectric effect? So the sufficient frequency of light అనేది సర్ఫేస్ ఆఫ్ ది మెటల్ పైన ఇన్సిడెంట్ అవుతున్నప్పుడు ఎలక్ట్రాన్స్ అనేది బయట రావాలి. The sufficient frequency of light energy will be incident on the surface of the metal, then the electrons will be ejected from that surface. So this phenomenon is called photoelectric effect. ఏదైనా లోహ ఉపరితలం పైన తగినంత కాంతి పడాల. తగినంత కాంతి అంటే తగిన పౌనపుణ్యం ఉన్నట్టు కాంతి. అన్ని కాంతుల వద్ద కూడా ఎలక్ట్రాన్స్ అనేవి బయట రావు. సో సర్టెన్ ఫ్రీక్వెన్సీ ఆఫ్ లైట్ అనేది ఇన్సిడెంట్ అయినప్పుడు దాని నుంచి ఏమవుతాయంటే ఎలక్ట్రాన్స్ ఎజెక్ట్ అవుతాయి. సో ఎలక్ట్రాన్స్ ఎజెక్ట్ అయినప్పుడు దీన్ని ఏమంటామంటే ఈ ఫినామినన్ మొత్తాన్ని ఫోటో ఎలక్ట్రిక్ ఎఫెక్ట్ అంటాం. ఇందులో వచ్చేటువంటి ఎలక్ట్రాన్లు, బయటకు వచ్చే ఎలక్ట్రాన్లని ఫోటో ఎలక్ట్రాన్స్ అంటాం. సో ఈ ఎలక్ట్రాన్లను బయటికి రావాలంటే కొంత పని చేయాలి, అండ్ అలాగే బయటకు వచ్చే ఎలక్ట్రాన్లకి కొంత వేగం అనేది ఉండాలి. సో దట్ ఈస్ ద కైనెటిక్ ఎనర్జీ. సో దాన్ని ఎక్స్పాండ్ చేసుకుంటూ వెళ్తే మీకు అర్థమవుతుంది. సో ఈ ఐన్స్టీన్ యొక్క ఫోటో ఎలక్ట్రిక్ ఎఫెక్ట్ ఈక్వేషన్ ఈ కింది విధంగా రాసినట్లయితే హెచ్ న్యూ ఇట్ ఈజ్ ఈక్వల్ 5 ప్లస్ కే మ్యాక్సిమం. కే రిఫర్స్ here it is the kinetic energy. So it is h nu, it is the incident energy. So incident energy it is equal to work function 5 it is the work function, and plus whereas kinetic energy of the emitted electrons, ke of the emitted electrons. So here we can say in another way, the incident energy on the surface of the metal will be equal to work function and also the kinetic energy of the emitted electrons. This is also one of the definition for photoelectric effect of the Einstein's equation. And here we can write it. So whereas h nu it is equal h nu naught work function, it is equal h nu naught plus kinetic energy, that is nothing but of m v naught square, of m v naught square. So here nu is the frequency and nu naught is the threshold frequency, h is the Planck constant, m is the mass of the electron, and v naught is the velocity of the speed of the electron. So here what is meant by work function? So what is meant by work function and what is meant by threshold frequency, that is nu naught. So here the definition for the work function, the minimum energy required to the electron eject from the surface of the metal. So here the minimum energy required to eject the electrons from the surface of the metal is known as the work function, that is nothing but h nu naught. So what is nu naught? Nu naught is the threshold frequency. It is the threshold frequency. So threshold frequency, it is the minimum frequency required to eject the electrons from the surface of the metal. So that is the threshold frequency. So threshold frequency here the minimum frequency, and the work function here the minimum energy required. Therefore the Einstein's equation, whereas h nu it is equal h nu naught plus of m v naught square will be written as, so here nu it is equal c by lambda, h c by lambda it is equal h c by lambda naught, and plus it is nothing but e v naught. So e v naught it is the stopping potential where it is measured in volts, and h naught is the work function, so that is in electron volts. So here it should be written as, whereas so the another form of the Einstein's equation. So from this, h is the Planck constant, c is the velocity of the velocity of the light. So then it can be written as, find out by the, so h value it is 6.626 into 10 power minus 34 joule, c it is equal 3 lakhs per meter per second. So here 12,400 by lambda it is equal work function phi naught in electron volts, and plus v naught it is nothing but stopping potential in volts. So this is the another equation for the Einstein's photoelectric effect. If you have required to find the lambda value, that is wavelength, then you can find, for suppose where is the work function it is equal 4 electron volts, and the stopping potential it is the 5 volts. So then lambda will be calculated by 12,400 by lambda, it is 4 plus 5, it is lambda it is equal 12,400 by 9. So in this way we have to find out the lambda value. So here one more question, that is stopping potential. So what is meant by stopping potential? So stopping potential it is nothing but the smallest magnitude of the potential at anode plate which just stop the photo current is called stopping potential. సో స్టాపింగ్ పొటెన్షియల్ అంటే ఫోటో కరెంట్ని ఆపడానికి ఎంతైతే పొటెన్షియల్ కావాలో ఆ పొటెన్షియల్ని స్టాపింగ్ పొటెన్షియల్ అంటాం. సో ది డినోటెడ్ బై వి నాట్. సో స్టాపింగ్ పొటెన్షియల్ అనేది ఎజెక్టెడ్ ఎలక్ట్రాన్ యొక్క కైనెటిక్ ఎనర్జీ పైన డిపెండ్ అవుతుంది. సో దిస్ ఈజ్ వెరీ వెరీ ఇంపార్టెంట్. కైనెటిక్ ఎనర్జీ ఆఫ్ ది కేఈ ఆఫ్ ది ఎజెక్టెడ్ ఎలక్ట్రాన్స్. సో ఇట్ వాజ్ డిపెండ్స్ ఆన్ ద కైనెటిక్ ఎనర్జీ ఆఫ్ ది ejected electrons. It should not be depends on the intensity of the light. It should not be depends on the, it can be depends, and not depends intensity of light. So not depends intensity of light. So intensity of light paina depend avadu, కేవలం ఎజెక్ట్ ఎలక్ట్రాన్స్ పైన మాత్రమే డిపెండ్ అవుతుంది. సో దట్ ఈస్ ద స్టాపింగ్ పొటెన్షియల్. సో స్టాపింగ్ పొటెన్షియల్ అనేది వెరీ ఇంపార్టెంట్ రోల్ని ప్లే చేస్తూ ఉంటుంది. సో కొన్ని గ్రాఫ్లలో మనం స్టాపింగ్ పొటెన్షియల్ గురించి ఎక్స్ప్లెయిన్ చేద్దాం. అలాగే ఇందాక వర్క్ ఫంక్షన్ చూసాం. వర్క్ ఫంక్షన్లో వచ్చినట్లయితే ద హైయెస్ట్ వర్క్ ఫంక్షన్ మెటల్ ఏదైతే ఉందో, హియర్ ద హైయెస్ట్ వర్క్ ఫంక్షన్ మెటల్ దట్ ఈస్ ప్లాటినం. సో it consisting of 6.35 electron volts, and the lowest work function metal that is cesium has only 2.14 electron volts of work function. So this containing platinum containing highest work function metal, and cesium is the lowest work function metal. So it means ప్లాటినం నుంచి ఒక ఎలక్ట్రాన్ బయట తీయాలంటే ప్లాటినం మెటల్ సర్ఫేస్ నుంచి 6.35 ఎలక్ట్రాన్ వోల్ట్స్ ఎనర్జీ కావాలి. అలాగే సీజియం నుంచి ఒక ఎలక్ట్రాన్ బయట రావాలంటే మినిమం 2.14 ఎలక్ట్రాన్ వోల్ట్స్ ఎనర్జీ రిక్వైర్ అవుతుంది అన్నమాట. సో అలాగే కొన్ని గ్రాఫ్లు చూసినట్లయితే ఫోటో ఎలక్ట్రిక్ కరెంట్కి ఇంటెన్సిటీ ఆఫ్ లైట్ గ్రాఫ్ గీసినట్లయితే సో ఈ విధమైనటువంటి మూలబిందు నుంచి పోయేటువంటి గ్రాఫ్ యొక్క షేప్ వస్తుంది అనమాట. సో ఇంటెన్సిటీ ఆఫ్ లైట్ ఇంక్రీజ్ అయినట్టయితే ఫోటో ఎలక్ట్రిక్ కరెంట్ అనేది ఇంక్రీజ్ అవుతుంది. ఈ గ్రాఫ్ని మీరు ఖచ్చితంగా ప్రాక్టీస్ చేయాల్సిందే. అండ్ అలాగే రిటార్డింగ్ పొటెన్షియల్ అండ్ కలెక్టర్ పొటెన్షియల్. సో ఇక్కడ గ్రాఫ్ గీసినట్లయితే ఫోటో ఎలక్ట్రిక్ కరెంట్ అనేది ఇటు ఎప్పుడు కూడా నెగిటివ్గానే చూపిస్తుంది ఫోటో ఎలక్ట్రిక్ కరెంట్, కానీ ఇక్కడ ఫోటో ఎలక్ట్రిక్ కైనెటిక్ ఎనర్జీ ఏదైతే ఉందో అది మాత్రం పాజిటివ్గానే ఉంటుంది. సో అది గుర్తుపెట్టుకోవాలి ఇక్కడ. సో హియర్ whereas potential V1, V2, V3, so here V3 is greater than V2 is greater than V1. So this type of graph should be very important, so please focus on it. అండ్ అలాగే ఇంకో గ్రాఫ్ ఉంటుంది మనకి స్టాపింగ్ పొటెన్షియల్కి ఫ్రీక్వెన్సీ ఆఫ్ లైట్కి. సో ఈ రెండింటి గ్రాఫ్ చూసినట్లయితే, సో మెటల్ ఏ మెటల్ బి చూసినట్లయితే, సో హియర్ దిస్ ఈజ్ ద minimum frequency, the threshold frequency will be here for the metal A, and this is the threshold frequency for the second metal, that is metal B. So where here nu is greater than nu naught and nu is greater than nu naught dash. So here photoelectric equation నుంచి మనం రాస్తే h nu is equal h nu naught plus ev naught. So ev naught is equal h nu minus h nu naught. ఈ నీటి వైపు తీసుకొచ్చినట్లయితే nu naught is equal h by e into v nu minus nu naught. ఈ h by e అనేది ఏం తెలియజేస్తుందంటే ఇక్కడ మనకి స్లోప్ని తెలియజేస్తుంది. సో దీని ఫార్మేట్ మొత్తం y is equal mx plus c ఆకారంలో ఉంటుందన్నమాట. ఒక ఈక్వేషన్ని పోలి ఉంటుంది. సో ఈ గ్రాఫ్స్ని మీరు ఫోకస్ చేసినట్లయితే ఇంకా అడ్వాంటేజ్గా ఉంటుంది. సో ఇంకా ఈ చాప్టర్లో మిగిలిపోయింది ఏంటంటే డి బ్రోగ్లీస్ వేవ్ థియరీ. సో డి బ్రోగ్లీ వేవ్ థియరీ చూస్తే, సో డి బ్రోగ్లీస్ వేవ్స్ థియరీ ఏం చెప్తుందంటే, it can be, so de Broglie wavelength lambda is equal to h by p. P it is the momentum of the particle, that is h by mv. So the relation between kinetic energy of the particle and the momentum of the particle, so ke it is equal p square by 2m. So then p square it is equal 2m k. K nothing but kinetic energy. P it is equal to under root of 2m k. So then we can write, whereas lambda is equal h by under root 2m k. So it should be written as k it is equal in terms of stopping potential, whereas h it is equal under root of 2m ev. E it is the charge of an electron, v it is the stopping potential, and m it is the mass of the electron. So here, whereas we can write the lambda value in angstroms. So if it can be written as under root of 150 by volts stopping potential in volts. So here, so this is the very important formula in terms of angstroms. And lambda of the gas molecules, lambda of the gas, so for the gas molecules it can be written as h by under root of, where it has 2m into 3 by 2 kt. So it is 3 by 2 kt is the kinetic energy of the molecules. So this is the lambda of the gas molecules, h by under root of 2m 3 by 2 kt. So these are the basic fundamental formulas for the dual nature. And one more here there is dual, that is the Heisenberg uncertainty principle. So due to the Heisenberg uncertainty principle, you can write that, whereas delta x into, where it is delta mv, that is nothing but momentum, it greater than or equal to h by 4 pi. So it means పొజిషన్ ఆఫ్ ది పార్టికల్ కానీ మొమెంటమ్ ఆఫ్ ది పార్టికల్ కానీ ఏదైనా సరే ఏకకాలంలో ఫైండ్ చేయడం కష్టంగా ఉంటుంది అనమాట. సో ఇది హైసెన్బర్గ్ అన్సర్టెనిటీ ప్రిన్సిపల్. ఇది మీ కెమిస్ట్రీలో కూడా బాగా యూజ్ అవుతుంది, ఆల్రెడీ చదివే ఉంటారు. సో వీటన్నిటిపైన ఇప్పుడు ఏవైతే చెప్పామో అన్నిటిపైన మీరు ఫోకస్ పెట్టినట్లయితే ఖచ్చితంగా ఈ చాప్టర్ నుంచి జేఈ నీట్లో 4 నుంచి 8 మార్కులు మీరు ఈజీగా సాల్వ్ చేయొచ్చు. టు అవర్ న్యూమరికల్ సెషన్. సో హియర్ దెర్ ఈజ్ ఎ క్వశ్చన్ విచ్ వాజ్ ఆస్క్డ్ ఇన్ 2017 NEET. The de Broglie wavelength of a neutron in thermal equilibrium with heavy water at a temperature T in Kelvin and mass m is. సో ఇక్కడ మనం de Broglie wavelength ఫైండ్ చేయాలి ఫర్ ద న్యూట్రాన్ పార్టికల్. సో ఇన్ టర్మ్స్ ఆఫ్ equilibrium with the heavy water at temperature T and mass of the neutron, it is the m. So here by the de Broglie's wave theory we wrote that. So where it is lambda it is equal h by p. So now we have to find h value and p value. So the momentum will be find out, then we have to get so the answer which are given in the options. So right, so how we can find the momentum? So here kinetic energy of the molecule, that is nothing but 3 by 2 kt. So 3 by 2 kt, and momentum of the particle in terms of kinetic energy, that is under root of 2m k. Already we wrote that. So from this equation, so how we can get that? So here p square by 2m it is equal kinetic energy, and P it is equal under root of 2mk. So k value will be substituted here. So P is equal under root of 2m, where k nothing but it is 3 by 2 kt. So 2 will be cancelled out. It will be written as it is under root of 3m kt. So T it is the temperature in Kelvin, m is the mass. Already here there are mass, it is the momentum. So hence we can write that lambda it is equal h by what is P under root of 3m kt. So this is the de Broglie wavelength of the neutron, which was the option A. It is the right answer. H by under root of 3m kt. H by under root of 3m kt. Here there is another question which was asked in 2016 NEET. Electrons of mass m with de Broglie wavelength lambda fall on the target in X-ray tube. The cutoff wavelength lambda naught of the emitted X-ray is. So ఇక్కడ చూసినట్లయితే మనం కట్ ఆఫ్ వేవ్ లెంత్ ల్యాండా నాట్ని ఫైండ్ చేయాలి మనం. సో దానికోసం కైనెటిక్ ఎనర్జీ ఆఫ్ ది ఎలక్ట్రాన్స్ రాసినట్లయితే కేఈ ఆఫ్ ది electrons. So K of the electrons it is equal to P square by 2m. The relation between momentum and the kinetic energy. So and here it can be written as where P it is nothing but by the de Broglie's wavelength we can write P is equal to h by lambda. So then h square by lambda square 2m lambda square. So that is the Ke. So here this is the kinetic energy, and the maximum kinetic energy in case of cutoff frequency by the Einstein's photoelectric equation, maximum Ke it is equal to hc by lambda naught, it is equal to h square by 2m lambda square. So h and square and h will be cancelled out. We need to find lambda naught. So therefore lambda naught it is equal to, whereas 2m c lambda square by where it is h. So this is the cutoff frequency, cutoff wavelength of the emitted X-rays, whereas the option it is the first option lambda naught is equal to 2m c h square by 2m c lambda square by, sorry, here it is the whereas lambda square by h. So this is the right answer. Option A is the right answer. Here there is another question. An electron of mass m and a photon have same energy E. The ratio of de Broglie wavelengths associated with them is. So here the ratio of the wavelength of the electron and the wavelength of the photon. So we need to find out lambda E by lambda P. So how much ratio it contains? There are 4 options are there. We need to find out. So here by the electron energy we can write that de Broglie's wavelength, where de Broglie's wavelength lambda it is equal to h by p. So it is equal to under root of 2m e. So here there is E, it is the kinetic energy, that is nothing but energy. So here this is equation where it is for electron lambda E. And coming to the photon energy, so for the photon energy E is equal to h nu, it is equal to hc by whereas lambda that is photon. And we can write from this lambda p it is equal to hc by E. So this is equation 2. So from for the question we can write lambda E by lambda p. So that is nothing but what is lambda E, h by under root of 2m E into by lambda p it is nothing but E by hc, whereas hs will be cancelled out. So then we can write off 1 by c, where root e into root e cancelled out, so it is under root of E by 2m. So this is our answer. So where there is we can write 1 by c into 2m by e, 1 e by 2m 1 by 2. So here it can be written as 1 by c e by 2m whole power 1 by 2. So under root will be replaced by 1 by 2. So option C is our answer. Here there is a question which was asked in 2016. When a metallic surface is illuminated with radiation of wavelength lambda, the stopping potential is V. If the same surface is illuminated with radiation of wavelength 2 lambda, the stopping potential is V by 4. So here when the wavelength lambda, the stopping potential is V. If the wavelength is 2 lambda, stopping potential is V by 4. The threshold wavelength for the metallic surface is, so the threshold wavelength, it is nothing but just you have to find out lambda naught value. So here the lambda naught value, is it 5 by 2 lambda or 4 lambda or 3 lambda or 5 lambda? Let us find out. According to Einstein's photoelectric equation, so stopping potential EV, it is equal hc by lambda minus hc by lambda naught. So here, so this is the EVS, it is the stopping potential. This is the basic equation. From this equation we have to write out. So where when it is the wavelength, it is lambda, the stopping potential is V. If the wavelength is 2 lambda, stopping potential is V by 4. So by this we can write, whereas EV, it is equal to hc by lambda minus hc by lambda naught. This is first equation as our first condition. If the same surface of the illuminated with the radiation of wavelength 2 lambda, lambda is equal to 2 lambda, and the potential, stopping potential is V by 4, V replacing by V by 4, EV by 4, it is equal hc by 2 lambda minus hc by lambda naught. So this is the second equation. From these two equations we have to find out the threshold wavelength lambda naught value. So from these two equations we notice that if the equation 1 will be divided by 4, then EV by 4, EV by 4, LHS will be equal, then RHS will be equal. So here we can write that, whereas HC by 2 lambda minus HC by lambda naught, it is equal HC by 4 lambda, because of we have to multiply it by 4, minus HC by 4 lambda naught. So now it can be written as hc by 2 lambda minus of this lambda will be come this side, hc by 4 lambda, it is equal hc by lambda naught minus hc by 4 lambda naught. So here hc will be common on both sides, then 1 by 2 lambda minus 1 by 4 lambda, it is equal, hc will be common, it is 1 by lambda naught minus 1 by 4 lambda naught, whereas hc will be cancelled out, it is 4 lambda will be LCM, here 2 minus 1, and here 4 lambda naught LCM, it is 4 minus 1, then we can write 1 by 4 lambda, it is equal 3 by 4 lambda naught, 4 will be cancelled out, it is lambda naught, it is equal 3 lambda. So here lambda naught is the threshold wavelength, whereas the answer it is option B, it is 3 lambda. Lambda naught is equal 3 lambda, which we are calculated. Here there is a question which was asked in 2013. For photoelectric emission from certain metal, the cutoff frequency is V. If radiation of frequency 2V, the impinges on the metal plate, the maximum possible velocity of the emitted electrons will be. So here, according to Einstein's photoelectric equation, we can write the maximum kinetic energy. Actually the equation is h nu, it is equal to phi naught plus, whereas Ke maximum, where Ke maximum it is equal to, we can write it is of m v maximum square, it is equal to, it is nothing but h nu minus phi naught. So whereas phi naught it is the work function, that is h nu, so phi naught it is the work function, that is h nu. So here simply we can write that nu, it is the where which was given to us, that is 2 nu. The frequency it is 2 nu. Frequency it is 2 nu. So cutoff frequency it is the nu. So then simply we can write that half m v square maximum it is equal to h into 2 nu minus phi naught, it is nothing but h nu. It is 2 h nu minus h nu, that is h nu. It is 1 by 2 m v square maximum. So we can find out v square maximum it is equal to h nu by 2 into h nu, 2 h nu by m, whereas v square v maximum it is equal, we can write under root of 2 h nu by m, where the option it is 2 h nu by m, that is option A. Here there is a question, if the momentum of an electron is charged by p, then the de Broglie wavelength associated by 0.5%. The initial momentum of electron will be, so here we have to find initial momentum. So p initial, how much it is? So by the de Broglie wavelength we can write, whereas lambda it is equal h by p, so it can be written as p is equal to h by lambda, where p inversely proportional 1 by lambda. So then we can write from this equation where delta p by p it is equal, where it is minus of delta lambda by lambda, because of lambda it is the reciprocal, we can take it as negative. So then delta p it is nothing but p momentum, p it is nothing but initial momentum, so it can be written as p initial into, whereas delta lambda where it is 0.5%, delta lambda by lambda it is 0.5%, 0.5 by percentage means for 100, so then it can be 1 by 2, it is 1 by 200, it is p initial by 200, whereas p is equal p initial by 200. Here also p by 200, this is not correct answer, so there will be asking initial momentum, so then p initial it is equal, we can write 200 into p, so that is 200 into p. So this is the right answer, where the option A is right answer. Here there is a question, electron used in an electron microscope are accelerated by a voltage of 25 kilovolts. If the voltage is increased to 100 kilovolts, so then the de Broglie wavelength associated with the electrons would. Here we need to find the relation between voltage and to the de Broglie wavelength. So from the de Broglie wavelength we was wrote that, so that is lambda it is equal to under root of 150 by V in volts. So here this is the formula which was discussed in at first. So then lambda inversely proportional 1 by root V, so it can be written as, whereas lambda 1 by lambda 2 it is equal to under root of V2 by V1. So now we can find out easily value the lambda 2 value. So if lambda 2, what option will be right answer? So here we can measure, so V2 is the, V2 it is the 100 kilo volts, so 100 into it is 10 power 3, so then V1 it is equal 25 into 10 power 3, it is lambda 1 by lambda 2, whereas 10 power 3, 10 power 3 it is 25, it is 4 times, it is lambda 1 by lambda 2 it is equal to root of 4, it is equal to 2, whereas lambda 2 it is equal, we can write that lambda 1 by 2, so hence we can say where the wavelength should be decreases by 2 times, decreases by 2 times, this is the right option. Here the next question, in photoelectric emission process from the metal of work function 1.8 electron volts, the kinetic energy of most energetic electrons is 0.5 electron volts, the corresponding stopping potential it is simple solution, that is we know already Ke maximum it is equal to EVS, where we can write that Ke maximum already given that So that was nothing but 0.5 electron volts. So that is 0.5, it is equal to EVS, whereas Vs it is nothing but 0.5. So here 0.5 volts is the right answer. So it is the last question. So the momentum of a photon of energy 1 million electron volts in kg meter per second will be. So here the momentum of a photon. So the momentum of a photon will be written as, from the de Broglie wavelength, lambda is equal to h by p. P it is equal to h by lambda, whereas we can write lambda is equal to h by lambda, it is equal to c by nu, where it can be written as h nu by c. So h nu it is the energy of the photon, then phi it is equal to E by c. So from this equation we can write that energy of the photon, that is 1 million electron volt. So it can be written as, it is 1 into 10 power 6 into charge of an electron 1.6 into 10 power minus 19 by speed of light, it is 3 into 10 power 8 meter per second. So it can be find out by nearly 5 into 10 power minus 22 kilogram meter per second. So whereas the answer it is option A is the right answer. సో ఈ వీడియో మీకు నచ్చితే లైక్ చేయండి, కామెంట్ చేయండి, మీ ఫ్రెండ్స్కి షేర్ చేయండి, సబ్స్క్రైబ్ చేయడం మాత్రం మర్చిపోకండి. థ్యాంక్ యూ.